really opposite aspects. You have to have a lot of holes in your rig to let the oxygen come in, and the lower the atmospheric oxygen, the more holes you need. But on the other turn, the more holes you have, the more water can evaporate out, causing death as well.
With each passing year, fewer Desmatasuchus are hatching. And those that do are not growing as large as previous generations. Their population will slowly ebb away in the coming years. Styracosaurus is quick to take advantage of the weakened Desmatasuchus. For Styracosaurus, walking upright eliminates the problem of carrier's constraint that plagues Desmatasuchus.
Once the limbs go straight under the body, they're not interfering with the internal organs in the torso, and that allows the lungs to expand more, to operate at a higher level.
Scientists theorize that they may have had extra air sacs that continuously circulated oxygen through their respiratory system. Today, this is the same feature that allows birds to fly at very high altitudes for extended periods of time.
The dinosaur lung is the same as a bird lung. A bird sitting here right next to me, breathing the same air I am, is going to extract about 1/3 more oxygen than I do. So you might say that, gee, this is a coincidence. Oxygen drops to its lowest point in 500 million years. The most efficient lung the world has ever seen appears. But evolution doesn't usually run for or derive from such coincidences. This really seems to be cause and effect.
A full-grown Desmatasuchus was once too large for Styracosaurus to take down. But now, this early dinosaur feasts on the struggling herbivores.
It would have been really unfair, really. You've got this creature which can run rings around you, whereas if you're the prey, you're trying to run away from this thing and you're gasping for breath.
Centuries pass. In North America, where the rifting first started, it seems that new fissures are erupting every day. The face of the supercontinent is melting like hot wax. The volcanic stranglehold tightens, with no end in sight. The Earth is morphing into a new world. But will it be a world filled with life or death? Heard the heavens fill with shouting and rained a ghastly dew. Alfred Lord Tennyson, 1842. "50,000 years into a terrible mass extinction, our planet is transforming into an alien world. Barren landscapes, skyrocketing carbon dioxide levels, thinning air. The daytime sky is tinted red. It's a scene expected on Mars, not on planet Earth. Global warming has turned lush jungles into tinder-dry forests. Wildfires are commonplace. Since there's no fire department in the Triassic world, these fires will burn until there's nothing left to destroy.
From space, it would have been fantastic. You would have seen this enormous black area, and perhaps even the forest fires, because as this stuff pours out, that tropical vegetation of the Triassic is going to catch fire. And so it's like a huge spreading cancer in the surface of the Earth.
The fires add more pollutants to the air, only intensifying the disaster. Rolling clouds of ash cover the landscape. Burying thousands of hapless victims. No one is spared. Rudiodons seek shelter from the storm, but their homes offer no protection. The water in Pangaea's lakes and streams turns to a cement-like paste. For the Rudiodons, the results are dreadful. The ash mixes with water vapor in the atmosphere, resulting in acid rain. It scalds the landscape, laying waste to whatever plant life remains.
We know from modern examples of acid rain that this quickly kills trees and other larger plants. And if it stops, then they will recover. But if this acid rain continues, and this may have been the case at the end of the Triassic, their root systems wither away and the soil is released. And then, of course, a shower of rain will have a devastating erosional effect.
This unending torrent of death strips the soil from the land.
We're having lots of runoff and erosion on the continents. This would tend to also pollute the oceans with a lot of minerals, dissolved minerals, and organic material being deposited in the ocean, making it fairly thick and soupy.
Now the disaster reaches into the oceans.
All that carbon dioxide, a lot of it gets pulled into the ocean and dissolved. But as it does so, it causes the oceans to get more and more acidic.
Microscopic plankton, the base of the marine food chain, dies in the hot, acidic waters. As a result, fish populations around the world are decimated. And as go the fish, so go all the creatures that rely on them for sustenance. All over the world, flocks of Eudomorphodon search in vain for fish that have simply disappeared. Pangaea's teeming rivers and pristine lakes are now stagnant. The dead bodies that litter the ground now provide an emergency food source for these flying reptiles. Under normal circumstances, Eudomorphodon would never scavenge a carcass. But hunger trumps all rules. It will hold them over for now. But it is not enough to stave off extinction. "70,000 years after the disaster began, starvation is now the norm for the animal kingdom. The world is barely recognizable. Taken day by day, the strangulation was slow, but the long-term effects are overwhelming.
We're starting to see now not just organisms dying out and disappearing, but new types of organisms replacing them. And in this particular case, it's not animals, it's bacteria.
This bacteria turns our once crystal blue oceans into dingy purple cesspools. The sky grows jaundiced. The whole world smells of rotten eggs. In what is now South Africa, one creature clings to life amid the suffering, our ancestor, Megazostrodon. Megazostrodon's instincts have served her well. Once again, her burrow protects her from the clouds of putrid gas. Like the early dinosaurs, Megazostrodon also has a more advanced lung design, but of a different sort than Styracosaurus. This small mammal has a sheet of muscle and tendon that separates its lungs from the rest of its internal organs, a diaphragm. This, combined with its small size, helps it breathe in the increasingly toxic atmosphere.
Body size is one thing that paleontologists love to look at. Did all these small animals at this time period go extinct? Or did all the large animals go extinct? And there's biological reasons why small or large animals might be affected at any single time.
In addition to this, Megazostrodon is one of the first animals in history to nurse its young. Mammary glands evolved from sweat glands. It's a key advantage. A female Megazostrodon uses her own body to keep her children fed, while the rest of the animal kingdom must forage. But will this be enough to save her species? The future of all mammals, including us, rests on her tiny shoulders. 250,000 years into a volcanic catastrophe, the Earth is unrecognizable. From space, the fissures can be seen stretching for thousands of miles, from modern-day Boston to Rio de Janeiro. The giant wounds are still bleeding liquid rock.
The volume that is believed to have extruded is incredibly large. Estimates put it on the order of 2 million square kilometers of magma being outpouring across all of these basins.
That's more than half the size of all the world's oceans today. The signs of mass extinction are sobering. Floodplains that once hosted thriving communities of animals are devoid of life. Where verdant rainforests once stood, only desert remains.
It's as if this very vegetated, wonderful world somehow gets perturbed to the point that we now have this desertification taking place over enormous areas of some continents.
Parts of the world, at least, it might have looked like the surface of Mars. I mean, if you remove plants, you lose the soil, and then you get a more extreme kind of situation. This may not have covered the whole world, but certainly parts of it.
In those few regions where life still exists, dinosaurs like Styracosaurus are rising to prominence. In addition to its advanced lungs, Styracosaurus staves off extinction by brooding its nest. Mothers lay their eggs partially exposed. Then they use their bodies for warmth or shade as necessary. This body contact allows a mother to fine-tune the temperature of her eggs, fostering a close, if not maternal, relationship with her young. And in the process, her species is rewarded with stronger, hardier offspring.
So while everything else is dying, it's as if we start getting more and more dinosaurs and bigger dinosaurs.
Equipped with these remarkable innovations, Styracosaurus is positioned to survive this catastrophe. Over 500,000 years after they began, the Camp basalt eruptions finally draw to a close. Pangaea is no more. The movement of the Earth's crust below has ripped the supercontinent apart. The liquid rock foundation for the Atlantic Ocean has been poured. The final death toll is almost unfathomable. 3/4 of the world's species are gone forever. The hardest hit on land are large armored herbivores like Desmatosuchus. The rudeodons are also extinct, another victim of a primitive lung design. But as gruesome as it is on land, the oceans are far worse off. Vast coral reefs that characterize the warm tropical Triassic Sea are almost completely gone. But incredibly, this isn't the end. Rifting that caused the mass extinction results in the opening of the Atlantic Ocean. The rest of Pangaea is following suit, resulting in the 7 distinct continents we know today. The world, our present-day world, is born. Some scientists theorize that this is part of a larger cycle of breakup and reattachment. One day the continents may be joined again as they were in Pangaea.
Why continents come together and why they pull apart is still a great mystery. We do know that the continents undergo something that has been called a Wilson supercycle, that every 200 million years or so, all the continents come together. It's kind of like bumper cars all arriving in the very middle of the place, smash together, sit together for some time, and then tear apart. And this coming together and tearing apart process takes about 200 million years. So that 200 million years from now, we expect they will all have come back together and collided once more.
In this brave new world, the first glimmers of hope begin to rise from the ashes. The early dinosaurs have managed to survive. Styracosaurus and its small cousins have proven their supremacy under the most severe conditions imaginable. Now the Earth is theirs. With the world void of competition, they multiply and spread out, creating new habitats and new species.
The dinosaurs really start to come into their own and start to evolve the many different forms that we see throughout the Jurassic and the Cretaceous.
The bigger, stronger, fiercer dinosaurs that evolve from this hardy stock will rule the animal kingdom for the next 150 million years.
There's no looking back. It's now the age of dinosaurs completely. The Triassic is this big crossroads. It was anybody's game, and yet now we have this big change in the world. We have lots of heating, lowered oxygen, and it's a perfect dinosaur world.
Beneath the feet of these giant lizards are the ancestors of modern mammals, the direct descendants of Megazostrodon.
If Megazostrodon hadn't made it through, we wouldn't be here today.
Resilient and well protected in its underground lair, Megazostrodon has made it through where so many others have died. Living quietly, Megazostrodon will thrive in the shadows. Waiting patiently for the time when its descendants will rule the earth.